Okay, so last class we were talking about graphing parabolas, and we started the lesson by discussing what a parabola is. So a parabola is a quadratic, it's a non-linear shape. It has the equation y is equal to x squared. We talked about the different parts like the vertex, the axis of symmetry, the x and y intercepts. We're going to go into those in more detail today. And then we talked about a little shortcut that you can use when you're graphing a parabola. So instead of making a table of values, which is time consuming, we have a shortcut, which is the 1, 3, 5 step pattern. So you start at the vertex and then you go 1 to the right or left, go up 1, then go up 3, then go up 5. And this always works, except in one example today, where I'm going to show you there is an exception and it's not going to work. Okay, so we practiced doing this. Any questions about this? The general shape of the okay. Then I told you that we're going to take our parent function, like the original parabola, and we're going to do a bunch of stuff to it. So we're going to move it side to side. We're going to move it up and down. We're going to reflect it, flip it over, and then we're going to stretch and compress it. And basically, those are called transformations, and we're going to do them one at a time. And finally, once we've done all 4 of them, we're going to put everything together and see what happens when all of them are applied at the same time. So the 2 transformations we went over yesterday were vertical translation, which means our parabola is either moving up or it's moving down. And the way that that looks in an equation is you have x squared and then the number after it. If the number is positive, your vertex moves up. If the number is negative, your vertex moves down. The second transformation we learned is a vertical reflection. So the way I think about it is if this is your x-axis, this is your parabola, a reflection means it flips down. So if it was facing up, like if this is your parabola, now it's going to face downwards. And the way that you see that in an equation is there's a negative sign in the front of it. Today, we're going to talk about horizontal translation and a vertical stretch or compression. I saved the funnest and hardest one for the end. And then we're going to put everything together and try to graph all of it at once. Samira?
So like, if before the test, when we're doing the vertical translation,
Yep.
then we have to be like, then to do the 1 through 5.
I would just give you the equation and I would tell you to graph it.
So we just like take the vertex.
Yep.
And graph that and then do the 1 through 5 from there.
Yep. Exactly. Hiroshi? There is, yeah, and we're going to talk about that today too. Okay, so let's get into it. Horizontal translation. Hopefully you guys all have the sheet. Take a look at the equation of a horizontal translation. Actually, just to do that, I'm going to go back to this. So over here, we can see that when you have something inside of the bracket, so you have not just the x squared, but you have x and then something with it, all of it squared. This means it's going to be a horizontal translation. One of the most important things I can tell you is when you have something that looks like this, do not expand it. So I know you're probably tempted to go ahead and foil it like we used to and expand it and open it up because we've been trained that whenever we have brackets, we want to get rid of them. But in this case, when you're graphing a parabola, if you have something in a bracket, don't expand it. Keep it exactly as it is. The rules for this are a little bit backwards. So if you have a number inside of the bracket that is positive, your parabola is actually going to move to the left. That's counterintuitive because usually you think moving to the left means negative. But in this case, if you have a number in here that's positive, you're going to move to the left. And then if you have a number in here that's negative, you are going to move to the right. So make a note of that. Counterintuitive, but that's how it works. Yeah. Keep this in mind when we do our 2 examples. Let's look at the first example. We have x minus 1, all of it squared inside of the bracket. This number inside of the bracket tells me that I have a horizontal translation. My parabola is moving either to the right or to the left. The number is a negative. So which way are we moving? Are we moving to the left or are we moving to the right? We're moving to the right. Okay, so usually our parabola start at 0, 0, right? That's the starting point. If I move my parabola 1 to the right, what is my new vertex? Be careful. There you go. Yeah, you were close. So it's going to be 1, comma 0. Exactly. I'll repeat myself one more time. When you have a number inside of the bracket, that tells me the parabola is moving either to the right or to the left. You look inside. If it's a -1 or negative any number, it means the parabola is going to be moving to the right. It's a little counterintuitive. It's opposite of what you would imagine. So we always start at 0, 0. That's our original parabola. We move it 1 to the right. So our new vertex is going to be 1, 0. Once you've put the starting point, the rest of it is super easy. You're still using the 1, 3, 5 pattern. So now what we're going to do is from this vertex, I'm going to go 1 unit to the right, up 1. Question?
Why did you write it like 1, 0, not 0, 1?
Because 0, 1 means the point would have been up here. You always write your x first and then your y. So we're moving 1 unit to the right. So that's right here. And then we're not going up or down. So it's just going to be a 0. Then we're going to go move 1 to the right and up 3. And then how many are we going to go up again? 5. Then whatever you do to the right, you have to do to the left. I'm going to pause this so you can't watch me. Are you guys okay with this example? Okay, go ahead and try the second example on your own. I'm going to do it on the screen as well, and then we can check our answer. Remember, it's a +2, so we're going to be going 2 units this time to the left. Yeah. Remember, I told you guys yesterday, math language is really important. If I were to ask you to describe this, you're not going to use the words like we're moving to the right, we're moving to the left. I want to hear the words horizontal translation, in this case, 1 unit to the right, and in this case, 2 units to the left. So highlight that, just make a note that those are the words I want you to use. All right, we're going to go to our final transformation, which it's not meant to scare you. It's not difficult. It's just, it's going to be a little bit different. And it's called a vertical stretch or compression. So the way I want you to think about this is, so everyone just take a look over here. Imagine your parabola is a balloon. Okay, so you're holding your balloon in your hands. And because it's vertical, we're going to put our hands at the top and the bottom because that's vertical. If it was horizontal, we would put them like this, but we're putting them like this. If I take my balloon and I stretch it out, what happens to that balloon? Does it become wider or narrower? Good. So when I vertically stretch a parabola, what's going to happen is it's going to end up becoming narrower. Okay, take that same balloon vertically, and now I'm going to compress it. I'm going to squish it. What's going to happen to the balloon? Is it going to become narrower or wider? Wider. Okay, so that means when we vertically stretch a parabola, it's going to become skinnier or narrower. When I vertically compress my parabola, it's going to become wider. Keep that in mind when we do the questions. How does that look in an equation? It's going to be a number in front of the x squared. And we're going to use nice numbers. So it can get messy, but because we're drawing it by hand, we're not going to give you any crazy fractions or anything like that. It's going to be pretty straightforward, nice numbers. Okay. So you know how you guys have been, and here is basically what I just said in a different form. It was so hard to find something that stretches, but that cat is doing a good job. So when you have a vertical stretch, when you're making your parabola narrower, that number in front of the x squared is going to be greater than 1. It's going to be a whole number. So it's going to be 2, a 3, a 4, a 5, a 6. Anytime you see a whole number greater than 1, you know that's going to be a vertical stretch. And what are we going to, and by the way, a vertical stretch means a narrower graph. So you know how you've been asking, like, will the step pattern always be 1, 3, and 5? The answer is it will always be 1, 3, and 5, except for when you have a vertical stretch or compression. So in this case, we're going to actually change our step pattern. And I'm going to show you how we're going to do that. First of all, is there a vertical translation in this question? Is the parabola moving up or down? Is there a number written like right over here? No. So there is no vertical stretch or compression. There is no vertical translation. It's not moving up or down. Is there a horizontal translation? Is the parabola moving side to side? No, because there's no bracket, right? If there was a bracket, then we would know that. So what is the vertex of this parabola? Hershey? Yeah, the vertex of this parabola is going to be 0, 0. The only things that affect the vertex is a vertical translation or a horizontal translation. But in this question, there is none of those. So we know we're starting at 0, 0. But we also see that we have a little 2 over here, and that is going to change the shape of our graph. We're stretching this parabola. It's going to become narrower than the original function. So how exactly do we do that? This is what you guys are going to do. You're going to write down your original step pattern 1, 3, and 5. And then whatever the number over here is, you are going to multiply to all 3 of the step patterns that we know. And we're going to get 1 times 2 is 2, 3 times 2 is 6, 5 times 2 is 10. And now this is our new step pattern. So we're going to start at the vertex. And now when we move 1 to the right, we're not going to go up 1, we're going to go up 2 units. Because basically the parabola is being stretched vertically. Every point is being pulled up. You can think of it kind of like that. I'm going to go 1 to the right. And how much am I going to go up next? Good. 1, 2, 3, 4, 5, 6. And now here's an example where we're not going to really be able to fit the next point. We can kind of estimate where it is. We're going to go up 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to think it's like around there. And that's okay. For stretches, we can't help but go off the grid because the numbers get so big. As long as you have like a good 4 points down, which we will because we're going to go on the other side, then you should be fine. Start back at the vertex, go 1 to the right, up 2. Sorry, 1 to the left, up 2. 1 to the left, up 6. And then 1 to the left, up 10. Samira, you have a question?
So like for the thing with number greater than 1.
Yeah. Yeah, I was saying that if you have a number in front of the x squared that is a whole number greater than 1, so 2, 3, 4, 5, then it's a vertical stretch. That means our parabola is being stretched up and it's becoming narrower. And to get the new step pattern, you multiply 1, 3, and 5 with that number 2. Yeah. Can you guys kind of tell this parabola is stretched, like is narrower? Can you see that it's being stretched? Okay. How do we describe this? We're going to say it's a vertical stretch by a factor of 2. So new terminology, just make sure you know that. Vertical stretch by a factor of 2. Brianna?
So it'll be a vertical stretch by whatever numbers.
Exactly. If this was a 3, let's say this was a 3x squared, then for our step pattern, we'd multiply everything by 3, and we would say it's a vertical stretch by a factor of 3. Now, if we're multiplying by 3, then we need a lot of space up there, right? Because the numbers are going to get bigger and bigger and bigger. Does this make sense? Okay, this is as hard as it gets. This is like, it's basically, this is it until we add a fraction, which is the next part. So here we have a vertical compression. Now, if you don't like fractions, you may not like this. How do I know something is a vertical compression? Well, in front of the x squared, you are going to end up having a fraction. So as soon as you see a fraction in front of the x squared, you know your parabola is being compressed, and so it's becoming wider. Okay, so one more time, A vertical compression means I'm compressing it and the parabola is becoming wider. And how do I know it's a compression? Because the number in front of the x squared is going to be a fraction. It's always a fraction all the time. Now, you guys, I could be evil and I could give you fractions that are insane. However, graphing insane fractions is very, very difficult because it's so hard to estimate what they would be. So I'm kind of limited in the questions I can give you. I would probably just give you maybe a half, maybe a quarter, and that's about it. The process is still the same. So let's go through it. So our question right here, y is equal to half x squared. Does this have a vertical translation? Is the parabola moving up or down? No. Does it have a horizontal translation? So what's our vertex? Good. So we'll identify our vertex. The only two things that affect the vertex are horizontal translation or vertical. The stretch does not affect it. The stretch only affects the shape of the graph and the step pattern. All right, now let's write down our step pattern, 1, 3, and 5. What are we going to multiply each one of these numbers by? Hershey? Yeah, we're going to multiply it with whatever number is in front, which is going to be a half. Okay, 1 times a half is just a half. 3 times a half is 3/2, but I want to convert it to a mixed fraction so it's easier to graph. So that's just 1.5. 5 times a half is 5/2, but I want to convert this to a mixed fraction, which is going to be 2.5. And that's all you do. Whatever the fraction here is, I could give you a third, I could give you a quarter, I could give you a fifth, a sixth, a seventh. You're just multiplying your step pattern by that fraction. I wouldn't give you anything messy like that because to graph those numbers is very, very hard. So like I said, I'm limited in the questions I can give you in terms of graphing so that it's a little bit easier for you. Samir? I'll show you why you should make it a mixed number and you can see if you want to or not. Okay. So now when we're graphing, we're going to go 1 unit to the right, and you may want to pay attention here. If you're a little confused with the fraction stuff, you may just not want to graph and look up here and then graph in a second. So follow along with my pen. I get start at the vertex. I'm going to go 1 to the right, and I'm only going to go a half up. You're estimating, but a half is pretty easy to estimate. So I expect you to get this kind of accurately, half up. We're going to do the same thing on the left-hand side. We're going to go 1 to the left and only a half up. And the reason I'm going a half up is because my new step pattern, which I multiplied by a half, is now a half. I'll pause here. Does this make sense? Anyone confused? Okay. Can I give you a number like 1/5? Would you be able to estimate where 1/5 is? Probably not. That's why you're probably going to get like a half, maybe 1.5, I don't know. Okay, let's do the next one. Now we're going to go up 1.5 units. So we start over here, we go 1 to the right, 1.5 units is going to take me to the number 2. So again, visualize it. You have from here to here, it's 1, and then another half is going to get me to a 2. Safir? Yeah.
So we already went a half already.
Yeah. Yeah. Sure. Yeah, that makes sense too. Now from this point, how much are we going to go up next? 2.5. Okay. So 1 to the right, move up 2 units. That's easy. And now just move up another half. And again on the other side. What do you notice about the shape of this graph already? Yeah, you can very clearly see that this graph is quite wide. And that's because it's being compressed. Every single point is being compressed towards the vertex. It's being squished down. And that's why the graph becomes wider. By the way, I don't think I labeled this graph. So let's go back here and label this. And I did not label this either. So let's go back here and label this. Oh, you know why? I'm zoomed in too much. How would we describe this graph? We would say it's a vertical compression by a factor of a half. So vertical compression by a factor of a half. How did you guys like that? Was that okay? Not bad? All right. We're ready to put everything together. What I want you to do is work with your partner on the first question and try to put everything together, and then we'll take it up in maybe 4 minutes. Okay, so the first thing you want to do when you're graphing is you want to identify the vertex. And in order for us to identify the vertex, we have to look at the horizontal translation and the vertical translation. Before we start this question, I want to label all the parts of the equation. So what kind of transformation is this positive 9 right here? Good. This right here is your, I'm just going to label it VT because I think I'll run out of space if I write everything. So I'm going to call this my vertical translation. What kind of transformation is this -5? Yeah, this is telling me which way I'm going. It's my horizontal translation. Okay, let's keep going. What kind of transformation is this 2? Najib? Good. How did you know it was a vertical stretch? It's a number in front of the X, but then how did you know it was a stretch and not a compression? Yeah. So the number in front of the X squared is whatever number is in front of the bracket. And because this is a whole number greater than 1, it's going to be a stretch. Good. And then last but not least, what can we say about this negative sign? What kind of transformation is that, Jennifer? Yeah, it's going to be our vertical reflection. So I kind of use short form. Hopefully you understood that. Now we're ready to actually graph it and see what happens when we put this together. So I always begin with the horizontal translation and the vertical translation because those are the only 2 things that give me my vertex. I start at 0, 0 because that's the starting point. How much are we moving to the right or to the left? We're moving 5 units in which way, right or left? Good. So starting at the 0, 0, I'm going to move 5 units to the left. So I'm hovering around this point. And then I have a vertical translation. How much is this telling me to go in which way? Up 9 units. So that means my vertex is landing where? Yep, Hamingi. What's that? 5, 9. Yeah. And when you do enough of these questions, you're going to start to notice a pattern. I'm not going to reveal it now because I want you to discover it on your own, but there is a pattern on how you can very easily and quickly figure out the vertex just by looking at the equation. Yeah.
So wait, a vertical reflection is like negative, right?
A vertical reflection just means that your parabola is now flipped over. So instead of facing upwards, it's facing downwards. So you don't, it's negative. It's like down. Yeah. It's a negative. Exactly. Yeah.
So also, so
Transformations is moving things around, and translation is a specific word for horizontal and vertical. So when I say vertical translation, it means I'm moving up or down. Horizontal translation, I'm moving side to side. And both of those are examples of transformations. Okay. Yep. Yes, this number, comma, this number, but you change the sign of this. So if this is a -5, you're going to put a +5 and keep the sign of that. But like I said, I'm not revealing that yet. All right, let's figure out the step pattern. There is a step pattern for this question. And I'm going to write down 1, 3, and 5. And what am I going to multiply all of those numbers by? I don't multiply it by -2. I only multiply it by 2. And I'll tell you why I do that. So I'm only going to look at the number. I don't really care for the sign. And the reason I do that is because all that sign is useful for is telling me which direction I'm going. So I know if there's a negative, I'm moving down. I'm not moving up. But in terms of the step pattern, I just care about the number. It's just the 2 that I'm actually worried about. Jennifer? You wouldn't get less marks. You can absolutely do that. It's not wrong.
So isn't that like the same?
It is the same thing. Yeah.
So you can do it?
You definitely can do it. Yeah. I just choose not to. I think I keep my negatives separately. I just think of it as a completely separate operation. All right. So now we're ready to put it all together. I'm going to start at my vertex, which was 5, 9. I'm going to go 1 unit to the right. And then how much am I going to go down? 2 units. Why am I going down? Because this negative sign is a reflection. Then why am I going down 2? Because there's a vertical stretch, so I had to multiply it by 2. Okay, I'm going to go 1 unit to the right again, and then how much am I going to go down now? 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. Good. And then I'm going to go 1 unit to the right, and I'm going to go down 10, and I'm going to do the same thing on the other side. So double check your graph. See if it kind of looks like what I've drawn here, probably a lot neater though. I can't do it. Okay, that's better. Kind of, not even, it's not even that nice. Y is equal to negative 2, x minus 5, all of it squared, plus 9. Yep.
You know, when you're doing it with your
Yep.
So
Okay, so when I'm describing my transformations in words, I start from the right-hand side and I just go in order. So let's start with the little negative sign, which is green in the picture. And I would describe that as a vertical reflection along the x-axis. And you would be required to do this. So when you're done doing a question, I would probably ask you to name all of the transformations, and then this is sort of what I expect. How about that 2? How would I describe the 2? Yeah, Krishna? Good try. Vertical stretch. You got that right. And then remember, I want to say by a factor of 2. Okay, how would I describe the negative 5 inside of the bracket? Hershey? Perfect. Horizontal translation. 5 units to the right. Okay, and then finally, how would I describe this positive 9? Safir? Yeah. Vertical translation. 5 units, 9 units up. Work. So in this question, there are 3 transformations. We don't have 4 because we don't have that negative sign. We have a vertical compression, we have a horizontal translation, and then a vertical translation. Before I started the question, I actually listed all of them. So we have a vertical compression by a factor of 1/2, horizontal translation 4 units to the left, and then a vertical translation 8 units down. And I'll keep this up after. What would be the vertex in this question, you guys? What do you think is the vertex? Mira?
negative 4 and negative 3.
Yeah, good. So negative 4 and negative 8. And how did we know that? Well, we know we're moving from the origin, we're moving 4 units to the left, then we're moving 8 units down, and that's where it lands us. We also realize that this is not working. There we go. We also realize that our step pattern is going to be changing because there's a half there. So just like before, we're going to go 1 times a half, which is a half. Then we're going to go 3 times a half, which is 3/2, which is 1.5. And we're going to go 5 times a half, which is 5/2, and that is 2.5. All right, so from our step pattern, from our vertex, we're going to go 1 unit to the right and up a half, and then 1 unit to the left and up a half. Then we're going to go 1 unit to the right, up 1.5, 1 unit to the left, up 1.5. And then we're going to do the same thing with 2.5. So just be careful with the halves. Your graph is not going to be very long. It's going to be very squished. It's going to be very compressed, and it's going to be super wide. And then don't forget to label y is equal to a half x plus 4 squared minus 8. And that's the end of the question. Did you guys get that? Good? All right. What do I want you to do now? I have given you, so like I said, we'll come back to this after, like the features of a parabola. I